This is going to be, I think, a record breaker for a high-speed version of tips and tricks. Because they're getting ready, or lunch ready next door, and nobody wants cold lunch. And I've got a couple of things I want to do. Like I said, we did the NS session over the last 2 days, so you're going to get 2 days and 30 minutes. Buckle your seatbelts. Actually, no, you're not. You're going to get my portion of the 2 days. The great part about the NS, and with here, as you saw earlier this morning, there are so many people smarter than me that can talk to almost everything. So the cool part of this job is I actually get paid to go out and find people smarter than me to talk about stuff, and that's a lot of fun and surprisingly easy. So I wanted to do grounding and lightning protection because those were the things that really seemed to, like I said, we read all of the feedback forms. There were 170 odd comments from last year, most of them positive. Some of them said I talk too much, but what are you going to do? Like I said, we're not going to listen to all of y'all. But grounding and lightning protection were the ones that really seemed to hit the high notes the most. And because everybody else ran long, we're going to do it fast. We're going to do it really fast if I can't remember how to hit the buttons. Now, we are also going to do a little bit of a case study. So what we're looking at here, two towers, two totally separate towers. One's from out west, one's from back east. They have one thing in common. It's easy to see on the right-hand tower. I'm going to use the laser pointer over here. Those people are going to have to guess. What I'm pointing at is the ground wire that's sticking out at a right angle to the tower. You know, a ground kit doesn't work really well. Now, number one, tower grounds, coax grounds, are not the best ground anyway. They're typically fairly long. They're fairly low gauge, relatively speaking. Tower climbers are not really good at scraping off the paint and giving you an antioxidant and giving you, number one, that stuff takes a lot of time, and number two, when you're dangling 600 feet in the air minus sub-zero temperatures, speed is of the essence. So, but that's the one thing these two have in common, no tower ground at all on the coax. Well, what happens if you get a lightning strike on a 600-foot lightning rod and a massive amount of current heads to Earth, and there's a long length of wire running in parallel? What do you got there? You got a capacitor. Let's transfer some of that energy from over here to over. That sounds like a wonderful idea, doesn't it? It does if you like after pictures. All right, so this is the other end of the one from back east. And what you can barely see in the left-hand picture is the rusted out U saddle clamp that is the only ground connection to that tower. There is a piece of 6-gauge soft-drawn copper going to a ground rod with another hose clamp, by the way. I should have taken a picture of that too. That was the only ground for that tower. Guess where all the energy's going? So I've got a piece of 6-gauge copper with a hose clamp, rusty hose clamp on, or a hose clamp to the ground rod, and then a rusty saddle bolt to the tower. And I've got this giant piece, relatively speaking, of 1 5/8" coax going straight into, a transmitter. By the way, this picture on the right, that's the AC ground. Well, you know what it is. Somebody heard me saying how much I dislike compression connections and say, well, we'll fix him, we'll just twist the wires together. So you got your AC ground there, you got your tower ground there. What I don't show you is the transmitter ground, which comes out a different corner of the building to a different ground rod. By the way, these ground rods are not connected together. Over the course of about 10 years, this customer has spent close to pretty close to $20,000 in repair parts, plus engineering time. I've discovered something about engineers. Y'all don't work for free. Why is that? John's talking about free transmitters, and the commission sales guy's sitting in the corner going, no, no, no. All right, so this is just an example of the stuff you run into. And in this case, bless his heart, the owner told me, he goes, it's a brand new site. It was built brand new, and it was a beautiful cinder block building. It's a nice building. He's got lots of air conditioning. Unfortunately, the air conditioning is blowing all the air past the transmitter, not through it, but that's a simple problem to fix. All right? And there was a little dust, and I'm looking, and it's like, this is a massive amount of air conditioning. Why do I see all this dust? Well, there's a half-inch gap under the door. So I found that. Tip number one, you ever figure out the way to find the gaps in your building? You go in the building on a bright sunny day, turn the lights off, and then just look for the glimmers of light. Well, it was easy to see the glimmer under the door. I never thought of that one. I think I've pretty much blown up my clicker today. There we go. Yeah, it's like, I've got nothing left to give. So we talk about grounding. The big thing about grounding, short, straight runs, as much as you possibly can. Okay, we don't want long, skinny gauge. If I can run strap, I'll take strap over or cable any day. Number one, a lot more surface area. Okay, a 4-inch or a 2-inch copper strap has got more surface area than a 2/0 cable. And relatively speaking, a 2-inch copper strap is a lot less expensive than a 2/0 cable. And if you're looking foot by foot, it's got 1/10 of the resistance. Now that's something to think about, because what we're playing is a game of current divider here. I want the current to go not through my equipment, ideally, or your equipment. It's always my equipment. You guys just pay a lot of money for the right to use it. It's like a long-term lease with zero buyout. I've been in sales too long. The other thing you hear talked about a lot is grounding versus bonding. They're two totally different terms. They're not interchangeable. Okay, grounding is where you connect stuff. Bonding is how you connect it. See that picture? That is a CAD weld mold. You know where I got that picture? Amazon's website. Think about this for a second. You can buy a mold that you can fill with thermite and set on fire on purpose from Amazon. I love this world. All right, exothermic connections, whether it's CAD welded, whether it's brazed, whether it's Silphos, silver soldered, I don't care, will beat a clamp connection any day of the week. Okay, I've done this so much that I think my hands automatically do it. I got to put the clicker down for this, but copper is malleable. Okay, copper is very soft metal. So if you put a stranded wire in a clamp connection and do not displace all of the air in that connection, the copper will deform to displace the air, and now you have a loose connection. So if you do have a situation where you got to put a stranded wire in a clamp connection, or even a solid wire as far as that goes, tighten it down, come back a week later and tighten it down again. Come back a month later and tighten it down again, come back a year later, tighten it down again, and then you can walk away from it. How many people have that much free time in their schedule? Because if y'all do, we'll need to talk about how you manage it, because I'm not doing it right. Okay, so we're doing the grounding. Other challenge I run into is overgrounding. Now, this is something a lot of people don't think about. You can have too much ground. And I've told this story a zillion times. Half of you have already heard it, I know. But I had a station in San Antonio, putting in an XL12. He calls me up and he goes, I got the ferrites on just like you like. And I said, cool, where? He goes, on the coax. And I said, wonderful. He goes, yeah, there's a problem. I go, what's the problem? He goes, it's hot. I go, what's hot? He goes, the ferrite. I said, well, ferrites shouldn't be hot. That means you get an imbalance current. Your feed and your return are not the same. We'll talk about ferrites in a second. It'll be a very brief second. I said, he goes, no, you don't understand. The transmitter's not turned on. He had the main transmitter grounded to the phaser, the main transmitter grounded to the standby transmitter grounded to the phaser, both of them grounded to the AC entrance, and the phaser grounded separately to a rod outside. And he had no idea where any of the current was going. You want to know the cool thing? That hot ferrite, when he turned the transmitter on, it wasn't hot anymore because it exploded. Problem solved, right? A little side note, I got to ask this, and I haven't asked this question yet today, and I usually do at least once. How many people have never been to a Nautel users group before? Awesome, well thanks, welcome. Side related question, because Gary's sitting there and I know he's keeping score. How many SBE members in the room? Awesome, excellent, thank you. Well, welcome for that. How many of y'all go to the Ennis sessions? Okay, I'm not seeing nearly as many hands this time, and most of you are on the board, so that's, I don't know, we got to work on that a little. All right, moving on. I'm not sure exactly what I've done to put these in the order I did. I was very tired at the time. Let's just go with that. I did discover that if you try to download a slide deck over hotel internet in Vegas, it takes a few tries. I should have used my hotspot. Okay, so this is a site in Chicago. This one was beautifully grounded, except, what did I say about, well, 40 slides ago, because I'm clicking through the duplicates, but short, straight runs as much as possible. Okay, the primary component of a lightning strike is in the audio range, coincidentally. Transmitters are designed to pass audio, coincidentally. So how we treat this is critical. Okay, there's also a high frequency component. When you add inductance, that high frequency component, no, I'm not going that way. Oh look, there's a transmitter, I'll go that way. Okay, short, straight runs whenever you can. Avoid loops, that's not straight. By the way, you don't need a drip loop indoors. Now, I'm not a fan either of running your ground wire through a steel conduit, because how many hams in the room? Few. How many of y'all have ever made an inductor by wrapping a piece of wire around it through a ferrite core? So you take a piece of wire, wrap it through some ferrous material, and make a choke that blocks high frequencies. Conduit is ferrous material. You run a wire through a conduit, you made a choke that blocks high frequencies. Lightning says, oh, I'll just go through the transmitter instead. Told this story a million times too. This is Springfield, Missouri. This is Kevin's fault. Because I was on the road, and I was in Quincy when we had the office there, and he's like, he calls up and he goes, what are you doing? I go, sales stuff, eating and drinking. He's like, can you go to Springfield? Well, I'm Quincy. Springfield, Illinois is only about an hour away from Quincy. I said, sure, I can be there in a couple hours. He goes, cool, they got a station's having some problems. Why don't you take Nelson down, go take a look. It's like, awesome. So this was right after Nelson started, so I guess it's more than a year or two ago. He meant Springfield, Missouri, which is not an hour away from Quincy, but that's okay, it was a fun drive. So we get to the site, and the first thing you do when you're looking at doing a lightning protection assessment or a grounding assessment, start at the tower. That's where the lightning bolt's going to hit first, that big multi-100-foot lightning rod. Pretend you're a massive amount of current. Follow it back, see where you end up. Anywhere you got a choice, decide which is the lower resistance. I mean, you can do that by observation in a lot of cases. So I start at the tower and I start walking back, and there's a beautiful 4-inch strap, nice shiny new 4-inch copper strap at the base of the tower. Hasn't been stolen yet, life is grand. So I follow it back and it goes to the building. And it goes right to the back of the transmitter. Now that on its own wouldn't be so bad, except there was one critical component missing. A ground rod. There weren't any. So the copper strap literally connected the tower to the back of the transmitter. Oh, that wire running up the left side of the transmitter, that's the ground wire to the surge protector. Through a conduit. Didn't we just have this discussion? See, it all comes together. It's like I planned it. That was the station reference ground. Somebody knows. Here's the thing. If you have to cut part of the footer plate of your wall away to get to your reference ground, to your ground rod, it's not a ground rod. It's the J-bolt designed to hold the building onto the concrete pad. Not an ideal ground. So we fixed that. We went to a ground rod outside, connected that ground rod, installed a ground rod at the tower, ran a piece of strap to connect the two ground rods together, keeping the impedances as close as we can, low resistance. Failure rate went down drastically. I won't say to zero, because, I mean, stuff's going to blow up. Eventually, if current goes through anything, current will eventually stop going through that thing for one reason or another. That's the only immutable law of electronics. That and high voltage hurts a lot. But as Stephen Lockwood said yesterday, you only touch the AM tower once. The other thing about ground, you can have the best ground in your building ever. Short, straight runs, low impedance, lots of strap, everything perfectly. But if copper thieves have stolen it outside the building, doesn't do you any good. So it does require some eyes on. You've got to physically look at this stuff now and again. Okay, especially these days. A little pro tip from Chris Alexander with Crawford Broadcasting. He wasn't able to be here today, but we'll be talking later. He paints all this stuff with roofing tar. Number one, it's not as shiny, harder to see for the crows and the drug dealers. Number two, kills the resale value. So, and it makes it a whole lot easier to identify the person trying to pry it off the building because they're covered in roofing tar. Okay, ground rods. Ground rods have an effective volume, an area of influence, electrode interface hemisphere. Plateway is saying that this ground rod is effective this far, typically just a little over the length of the rod that's underground. If you take an 11-foot rod and only stick the bottom foot into the ground, then your interface hemisphere is a foot and change for a radius. The reason I bring it up, because a lot of people say, I got an 8x8 building, I put a ground rod at each corner and one in the middle, and I got two more over there and four by the tower, and it's like, wow, you just wasted a lot of copper and a lot of energy. Okay, it's not that it'll hurt anything, you're just wasting time. Okay, two ground rods drilled 8 feet into the ground, spaced a foot apart, is equal to one 8.5-foot ground rod, or 8 foot and 5 inches. If you're going to do two 8-foot ground rods, put them 17 feet apart. Now you've really improved the effectiveness. Told you we were going to talk about ferrites again. So, somebody told me I should get one tattooed on me, but after watching Greg Buchwald from Motorola talk about Ohm's Law 2 days ago at the NS, I want the Ohm's Law wheel. The EIRP, yeah. That'll be my next ink, first ink, whatever ink. All right, so ferrites, how does a ferrite work? You got a feed and a return, and a round circle of ferrous material, basically carbon, iron filings, and epoxy to hold it into whatever shape. As long as the feed and the return are equal, the ferrite's just a lump of carbon and iron filings. Okay, if you have an impedance, or a bump, not an impedance, a voltage spike, so you get a lightning strike discharging, then the ferrite will saturate and effectively induce an equal spike into the opposing legs. So the potential difference stays closer to the same. It's not 100% efficient, but it's an improvement. Is a ferrite on its own going to do anything? No. If you get a big enough strike to cause damage, a ferrite all by itself with no grounding is probably going to explode, like the guy in San Antonio found out. But with good grounding and surge protection, remember, again, we're playing current divider game here. Every little bit helps sometimes. Okay, if you've got the grounding and the surge protection and don't have ferrites, you're probably going to be okay. But if you're starting to see a few failures, then maybe that'll make the difference. Now, if you didn't have failures before and you do have failures now, the first thing you got to figure out is what changed. Okay, sometimes your ground system isn't there anymore. Or your surge protector's got a failure. Okay, but anywhere where you have a feed and a return, you can put a ferrite. Coax lines, audio lines, power cord, don't care. Anywhere where there's a feed and a return, you can put a ferrite. Okay, mention the surge protector. So surge protector is an MOV, or, well, they're not always. There's silicon avalanche diodes. There's 2 or 3 different configurations. MOVs are the most common, metal oxide varistors. It's basically a big clamp. It's got a voltage rating. When the voltage across it exceeds that rating, it clamps, becomes a short circuit, shunting that energy to whatever's connected to the other end, usually ground. For that reason, they need to be fused. Ideally with a properly rated fuse. As one of our customers discovered, a 7/16" bolt, not a properly rated fuse. An MOV, when it does fail, because it's cumulative decay, so they'll only absorb X amount of energy, whatever they're rated for, and they'll take a couple of joules this time and a couple of joules that time, and then they'll hit the limit and they'll fail. Always. 100% of the time, they'll fail short circuit. If they're not fused with a suitably rated fuse, after they fail short circuit, they'll fail open circuit in a very dramatic fashion. They go boom. I had to say it at least once. Anybody who's been here before knows. So we don't care whose surge protector you use. We use Raycap these days. We've made our own in the past. LEA makes great ones. Transsector, Polyphaser, Control Concepts. Pick your favorite. Don't care. Make sure you have surge protection. Because without the surge protection, you don't have the complete puzzle. Okay, I'm going to skip past this one and go to that one. Reason being, almost 100% of our transmitter sites are built wrong. Antenna out back, big lightning rod out back. Power line out front, more energy. Let's hang all of our gear in between those 2 places. What could possibly go wrong? And so what we want to do is this. Okay, that right there in a nutshell is easy. It seems so simple, right? How hard could it be? The surge protector is the thing, the bypass, if you will, the path between power line and ground. Okay, remember, we got a multi-100-foot lightning rod back there. When you dump a massive amount of current down this thing, Earth has a resistance, unless you've got it totally paved with copper, which I'm willing to bet most of you don't. Now say Earth has a resistance of 3 ohms per foot. 9 ohms between my feet. Wrap your head around this for a minute. Remember I mentioned the Ohm's law wheel earlier. What's Ohm's law? E equals I times R. Exactly. 9 ohms. Run 100,000 amps down that tower. What's 9 times 100,000? Even I can do that math after a week in Vegas. 900,000 feet between this foot and this foot means Jeff's having a bad day. That's why they always tell you to, in a lightning storm, if you're stuck in the field, put your feet together, crouch over and kiss your, put your feet together. All right? So it's both because we're going to spike ground potential high here as that energy tries to dissipate outwards. We can clamp this surge protector and dump a lot of it out on the power lines where the power company graciously provides millions of miles of conductors for energy to dissipate on. And lots of surge protection and grounds. Okay? By the same token, if you do happen to get a power line hit, not so common in urban centers, but much more common if you're at the end of the line in a rural area, surge protector will clamp and shunt that energy to ground. Either way, it's going past my equipment, not through it. And that's the whole goal of grounding and lightning protection. Now, in this case, we've thrown a couple of ferrites on there. Like I said, matter of degree, we're just raising that impedance a little bit so that it makes an even less attractive path through my equipment. Like I said, always going to be my equipment. Okay, now if you've got an existing layout, you can do some things. You can reroute the cable. Okay, Put your common point, your reference point ground over by the main panel. When you have a choice, put your surge protector by the main panel, because the wiring to the surge protector will almost always be higher resistance than the strap from the surge protector to ground. Make sure it does have a ground connection too. Okay, so close to the panel as you can get, run your strap over to it, life is grand. Okay, ground your coax shield, because as we've discussed, the grounds on the tower aren't really doing a whole lot except to break up the capacitor. Okay. I mentioned before about the air handling. Air handling is something done wrong more than it's done right. There are so many sites where I've walked in and they'll be blowing 10,000 cubic feet a minute air through the building, but they're blowing it right past the transmitter. Well, what are you doing then? You're creating negative pressure and sucking air out of the transmitter instead of feeding it in. Okay, we don't need the text. So instead of doing this, we need to not do that, do this. Run the air through the equipment. How many people have got those barred air conditioners, you know, the ones where they dump the cool air out the top and the hot air return down below 180 degrees backwards for what we want in a broadcast facility? It's great for anywhere where you've got people, because cool air goes out, filters down, cools the person without blowing air draft in their face. Life is grand. Transmitter doesn't care how comfortable you are. Okay? If you have a situation like that, find your local sheet metal guy, give him a couple of grand, create some ductwork, bring the cool air down. Almost every transmitter on the planet, don't care whose brand it is, brings the cool air in at the back near the bottom. Now, like if you look at our big FMs, it brings air in the front too, and that's important because that's cooling the power supplies. Okay, other manufacturers, they may have a little maze of air tunnels to cool stuff, so you got to bring more pressure in so you don't have the back pressure slowing down and causing hot spots. Pay attention, talk to your manufacturer, okay? These are the kinds of things that are relatively easy to fix, but they're still done wrong more than they're done right. As an example, so this big round flex duct was the cool air coming into the room. The duct down at the bottom, I don't know if I can hit that one from here. Oh, look at that there, I'm pretty good at this game. That's the hot air return. The little gray box that you can barely see at the very back, that's the transmitter. And what we're doing in this case is pulling the air away from the transmitter intake. Coincidentally, their failure rate was higher than expected. So all we did, we just rerouted that big flex hose, dumped the air down behind the transmitter, and then added a little ductwork to bring the cool air return up to ceiling level. Failure rate went way, way down. The cool thing about this site, this was an involved owner. This guy was amazing. I've got pictures of him brazing the ground connections because I don't like clamp connections. 9 o'clock at night by a set of headlights, he's brazing his ground connection. That's the kind of owner you want to work with. We don't always get that option. And let's see, I'm going to take a couple of minutes when we wrap this up, and we'll take a segue because I want to have a chat about that too. Okay, also with air conditioning, don't oversize. Okay, an air conditioner that's too big is almost as bad as one that's too small. You can either not remove enough humidity from the air and cause, now not here where humidity is measured in single digits. Holy smokes, it's dry. But in a lot of places, like where I live, humidity is typically 70+%. And if you've got too much air conditioner and it's not cycling often enough, all you're doing is helping that humidity increase. Okay, anybody from Florida knows what I'm talking about. Okay. There are only 3 things you need to take away from this presentation. 3 words: cool, clean, grounded. Okay, if you keep a transmitter cool, clean, and well grounded, I don't care whose logo on the front, I don't care how old it is, I don't care whether it's tube or solid state, it's going to live a lot longer. If you fill it full of dirt and let it run hotter and stink, it's not. And again, I don't care whose logo's on the front. Same with all your equipment. It's funny how when you fill a bowl insulator full of ant farm, whenever it gets a little moisture, weird things happen. Okay, so like I said, cool, clean, grounded. Those are your takeaways from that. All right, so I'm going to do a little sideway. Oh, and if anybody's interested in ferrite, grab that screenshot. There's a bunch of links if you want to learn stuff. It's kind of, and I can provide anybody a copy of this slide deck. You don't have to take a picture, but it's up to you. It was just some stuff. You'll notice the bottom one's a ham radio one. I'm not a ham, but there's a lot of cool innovations in technology in the ham website, so it's a fun place to learn stuff.